So for this first problem, when you're doing a square root of a fraction, the easiest thing to do is to take the square root of the numerator and the square root of denominator and then just leave your answer as a fraction. So there's a negative out front. The negative stays out front. And then what is the square root of 1?
Isn't it just 1?
Yes, very good, because 1 times 1 is 1. And then what is the square root of 4?
2.
2. Yep. So your answer here would be 1/2, and then the negative stays out front. For number 2, you would be able to just type that directly into your calculator. Do you guys have calculators with you right now? You should be able to type in the 0.0121 and then hit the square root button. So 0.11. Very good. Number 3, there's a negative out front, so that's going to be part of our final answer. And then what is the square root of 4?
2.
2. Yep. So our answer will be -2. Now for variables, let me do these two problems. Let's see. One way to think about the last problem, right, is you could think of the square root of 4. I know you didn't do this, but you could think of it like you broke down the 4 into 2 times 2, right? And because there was a pair of 2's, that's what allowed you to get a 2 outside of the radical as your answer. You can do that strategy here in case you want to tie the variables back to what you do with regular numbers, because x to the 8th is actually 8 x's, right? Being multiplied together. I think that's only 7, 8. So you can think about it that for each pair, you bring an x to the outside, right? So you can be like, okay, well, there's 1 pair here, 2 pairs here, 3 pairs here, 4 pairs here. That's 4 pairs of x's. So that means there's going to be 4 x's, or x to the 4th, outside the radical. But the shortcut that we teach you is that a square root is really like having an exponent of 1/2, like you learned about. So you can really just take the 8 and multiply by 1/2, which is the same as saying you can take the 8 and divide by 2, which is the shortcut that we teach you, that you can take whatever your exponent is, and if you're doing a square root, just divide it by 2, but it's really because you're looking for those pairs. Okay, what about this one? Negative the 4th root of 16. So what number times itself 4 times gives us 16?
2.
And then the negative stays, right? So it'd be -2. I'm sure we'll get to it later, but what would happen if I had given you this problem? What would happen if I moved the negative inside the radical?
You have to pull out the negative.
So you can do that when you have what kind of root?
Oh, I'm thinking of more further out.
Yes, but also it only works with square roots.
Yeah, so that's, you can't solve that. That's
Correct. That'll be not real. If it was this problem. Because if you took -2, let's say you thought that would be the answer. The problem is when you multiply -2 by itself 4 times, you end up with a +16, not a -16. So there's no way to get back to the negative. Okay, this one, there's a couple ways to do number 6 and 7. One way is to actually work them all the way out, or the other way is to know the shortcuts. And we can go over both ways because it doesn't hurt. So if you don't remember the shortcuts, which is fine, -6, when you square it, becomes +36, right? And then what is the square root of 36?
6.
6. Okay, and then for the other one, -6 cubed is -216. And what is the cube root of -216? If you have a calculator, it'll tell you that the answer is -6. The shortcut is when you do a root of a power, they cancel out and you just get the number. But if it's an even root, like in number 6, where this was an even root and an even power, then you get the absolute value of the number. If it's an odd root, here you had a cube root and a 3rd power, then you get the actual number. You don't get the absolute value of the number. But if you don't know the shortcut, not a big deal. I wanted to show you can still work it out.
Wait, how did you get -6?
the cube root of negative 216. So you would do that on your, potentially on the calculator. I'm not sure what capability your calculator has. The other way is you could work backwards. So you can make yourself a table. Sometimes I recommend this depending on what your calculator can does, because you can always work forwards. So 1 cubed, you could do 1 times 1 times 1 on your calculator and it would tell you the answer is 1, right? And then 2 cubed, 2 times 2 times 2, you could type into your calculator and it'll tell you the answer is 8. 3 cubed is 27. So even if your calculator does not have a cube root button, I'm not sure exactly what functions are on your calculator, you can always do this, right? Because you can always multiply on the calculator. 5 cubed, 5 times 5 times 5, you would type in, is 125. And then 6 cubed is 216. You could keep going. I'm just going to stop there because that's the number we needed. That means if 6 cubed is 216, that tells you that the cube root of 216 is 6.
Got it. Thank you.
But that's a great way to make that list to help you with these problems, especially if your calculator does not have a cube root button or a fourth root button. That's the way to do it, is work, kind of list them out and then work backwards from these numbers to come up with these numbers. Okay, so let's check out this one, number 8, square root of 49, a to the 8th power, b to the 40th power. So first, let's just do the number, then the a's, and then the b's. So what is the square root of 49?
7.
7. Very good. And then how would you handle a to the 8th?
A to the 4th.
Very good. Divide the exponent by 2. Good. And then the square root of b to the 40th?
B to the 20th.
Awesome. Nice job, guys. Okay, what about the next one? The square root of 4/25.
Wouldn't you like separate the square root to where it's square root of 4 on the top and then square root of 25?
Very good.
That would be 2 over 5, right?
Yes, very good, guys.
Don't you break it up the same way?
Very good. So what is the square root of x squared?
X.
So for the denominator, what do we get?
9y.
Okay, for number 11, we're going to write the expression using radical notation. So I just mentioned a minute ago, but m to the 1/2 is the same as what kind of root?
Square root?
Square root, very good. So this would become, so this is my question. Which of these answers is correct? This answer or this answer? So is it the square root of 5m or 5 times the square root of m? Which answer is correct and why?
The 5 times the square root of m.
Very good. Why is that correct, Marla?
Because the half is only the exponent for the m.
Good. So for this problem, that would be the answer. Very good. For this, it would have to say 5m in parentheses raised to the 1/2 for the 5 to also move inside the radical. Very good. So if you have a 1/2 power, it's the same as a square root, but we normally don't write the little 2. So it's assumed if you just write a radical without a little number that there's a like invisible 2 there, right? So here, when you have a 1/3 power, that means that you're doing a cube root. So you have a cube root of -125, which you might have that button on your calculator, or we can go back to the list I made a few minutes ago. So based on this list right here, what is the cube root of 125? We'll worry about the negative in a second, but what is the cube root of 125?
It's 5.
5, right? So we can use the list to figure out the answer. So you can do that, make the list once on your test and then refer back to it if needed. So then here, since it was the cube root of -125, the answer would be -5, right? Because the negative times the negative times the negative again does give you a negative answer. Okay, how would you rewrite number 13?
Wouldn't it be 6 on the outside and then radical and then inside the radical, negative 64.
The negative would be on the outside.
Yeah, yeah. Thank you.
Very good. Yes, the negative would be on the outside because kind of like the problem that was 5m to the 1/2, right? Only the m was being raised to the 1/2. Here, only the 64 is being raised to the 1/6 unless the negative was in parentheses with the 64, but it's not. So it's on the outside. So what is the 6th root of 64? And this one you could also work backwards and say, okay, what is 1 to the 6th power? What is 2 to the 6th power? Until you come up with the 64.
It's 2.
It's 2. So your answer here would be negative 2. Very good, because 2 times 2 times 2 times 2 times 2 times 2 is 64. What about number 14? How would you rewrite that?
So that would be 4 on the outside to negative 81. And then it's cubed. The 81 is cubed.
Very good. So the denominator is your root. The numerator is your exponent. So in the other problem, since the numerator was 1, that's why we never had to write an exponent on the inside. But this time we do. What do you know about this answer, though?
The answer is not a real number.
Why is it not real?
I went over this with my aunt because she's a math teacher, but she said that if
so if it's odd, you can work it out like in, let's see, this problem, number 12, right? If you have an odd root, you can get an answer. If it's negative, you'll get a negative answer. But if you have an even root, and this ends up being negative even when you cube it, so if you have an even root of a negative number, that's when it's going to be not real. Because there's no way, if you multiply a negative number an even number of times, it always gives you back a positive answer. That's the problem. So you're not going to get back to a negative answer. How would you rewrite number 15? With positive exponents only. How can we get rid of that negative exponent?
Do you divide it?
Yep, throw it down in the denominator to make it positive. Yep, 1 over x to the 3/4 power. Very good. So these are rules that you learned before back in module 3, right? You learned the exponent rules. The difference now is that we're now using the same rules with fractions as your exponents instead of just integers as your exponents. So when you multiply, what do you have to do with the exponents in number 16?
Or you just add them across.
Add them across. Good. And the good news is they have a common denominator, right? So what is 3 over 7 plus 8 over 7?
11 over 7.
Very good. Add the numerator, keep the denominator the same. So that's your answer, d to the 11/7 power. So let's do the same thing for number 17, right? We're multiplying, so we're going to add the exponents together. So what is negative 2/5 plus 7/5?
Wouldn't it just be x because it would be 5 over 5?
Exactly, it'd be 5 over 5, which is just 1, right? So then you would have like x to the 1st power, which I agree with you is just x. Very good. Then you could think of the x to the negative 2/5. So I'm going to keep this in the top, but you could move that to the bottom, kind of like we did a problem or two ago with the 3/4 when it was the exponent.
Oh, okay.
And then you could actually subtract them. That would be another way you could do it.
Okay.
So you could do 7/5 minus 2/5, which still gives you 5/5. So you still end up with the same answer.
Okay.
But if that's another way to conceptualize it, which I actually think you sometimes do the problems like that, don't you? Isn't that how you were doing them?
Yeah.
In the 3rd module?
Mm-hmm.
Okay, so what do we need to do in number 18 here?
Don't you multiply to get the denominators the same?
And then what are we going to do with the fractions?
Subtract.
Subtract them. Very good. But you're absolutely right. We would need to get a common denominator. So we're going to have to do 1 over 10 minus 1 over 20. So how could we turn 10 into 20? What do we need to do?
Multiply by 2.
Good. So now we have 2. Oh, I don't know why I wrote 20. I'm sorry. I jumped ahead of myself. Now we have 2 over 20 minus 1 over 20, which gives us 1 over 20. And of course, all of that is our exponent, right? So our answer would be y to the 1 over 20th power.